Welcome to this tutorial on how to configure the GFDM transceiver implemented by the Vodafone Chair. GFDM is one of the waveform candidates for 5G. Multiple studies have already shown the potential of this waveform to fulfill the requirements of 5G. And the GFDM group has implemented a flexible GFDM transceiver on a National Instruments software-defined radio platform. For the development, LabVIEW Communications Design Suite 2.0 and USRP's 2953R with 40 and 120 MHz bandwidth have been used. The connection between the control PCs and the USRPs is done via PCIe 8371 cards. In this tutorial, we consider a basic setup consisting of a control PC, one USRP acting as a transmitter and as a receiver, and antennas for the transmission over the air. The code with the LabVIEW implementation is available online in a GitHub repository. You can find this link on the description box. We can download the zip file with the code, and we have to extract it to the hard disk drive. Here we can see the folder structure of the project. And under documentation, you can find a PDF tutorial with more detailed information about the configuration of the transceiver. Once the code is extracted, we can open the project with LabVIEW Communications Design Suite. Afterwards, we will open the GFDM host VI. This is the host VI. It's the user interface, and it allows us to configure the parameters of the transceiver. The first parameter we have to configure is the USRP RIO device, and for this purpose we can use the National Instruments Measurement and Automation Explorer. We also need to configure the reference frequency source. Each USRP needs a reference frequency of 10 MHz to derive its clocks, and we need to select this source among internal. If the USRP uses an internal reference clock, ref-in is this reference is taken from the ref-in port, or GPS if we are using a GPS device for more accuracy. Now we will go through the configuration tabs, and we will focus on the most important parameters. Please refer to the PDF tutorial for more information. Let's start with the DX tab. Here we need to select the transmit carrier frequency in Hertz. Our license allows us to transmit at 1.99 GHz. If you are running this project with antennas, please make sure that you are in compliance with all local laws. We also need to set a sampling rate in samples per second. We will set it to 10 MHz. And here we can configure the GFDM parameters, where K is the number of subcarriers, M is the number of subsymbols, A is the roll-off factor of the prototype filter, and can take values between 0 and 1. The prototype filter can be chosen between raised cosine and a rectangular filter. At the receiver, we can select zero forcing or match filter. Inverse FFT is an internal parameter, and we will left it to off. In GFDM, we perform time domain windowing, and V refers to the roll-off factor of the time domain window. It can take values between 0 and 1. NCS is the number of samples of the cyclic suffix, and NCP is the number of samples of the cyclic prefix. Let's continue with the RAX tab. Here we also need to select the received carrier frequency, in our case 1.9 GHz. The sampling rate will be set to 10 MHz. And now we can find some gain-related parameters. The receiver can work with a fixed or with an adaptive gain. We will choose off for an adaptive gain. The parameter switch channels indicates which channel is used for the reception. In our case, we are using the RF0 for the transmission and RF1 for the reception. And we can also configure some synchronization parameters. The synchronization module needs a threshold to determine if the synchronization has been found. And this threshold can be fixed or adaptive. We will work with an adaptive threshold so that the synchronization algorithm can work properly with different power levels of the received signal. We can also determine if we want carrier frequency offset compensation or not. Let's continue with the Data tab. Here, we can select the payload size in bytes. And with data routing, we indicate where the input data to the transmitter comes from. The data can be sent from the host to the FPGA, or can be obtained via UART if the auxiliary input-output port of the USRP is used. We will select data from host. If read UDP is set to off, the data will be generated on host as a RAM function. We will select on to get the data via UDP. This means that the transmitter will receive the data as UDP packets from the video streaming server, and the receiver will send the output via UDP to the player to be displayed. UDP receive port refers to the UDP port number used to receive the data from the video stream player, and UDP send port is the UDP port number used to send the data to the video stream player. In order to work with communication via UDP, we need to configure the transmitter and the receiver. Here we have the commands we need to execute, but let's do it on the GFDM transceiver. Here we have the GFDM host. Let's see how to configure the USRP real device using the National Instruments Measurement and Automation Explorer. We can search for devices and we will find our USRP. The model USRP 2953R 120 MHz bandwidth. This is the name of the USRP and this is the identifier. In the configuration tabs, we will leave the parameters to their default values, and we will change the roll-off factor of the prototype filter and the roll-off factor of the time domain window. In data, we select data from host and we activate read UDP to on. Now we have to configure transmitter and receiver to work with UDP. We have already the commands here. We are working with VLC Portable. This is the name of our video, and we used repeat because we want to guarantee continuous transmission over a long period of time. And this is the receive port. Now we configure the receiver. And we will start the project. The GFDM transceiver is running. And we can see the constellation with the IQ receive symbols. We can also see different parameters from the modules of the transceiver. For instance, for the calculation of the gain, this is the received preamble, which is used for synchronization and channel estimation. These are synchronization metrics, and this is the estimated channel in frequency and in time domain. And now we should see the video with the data that the receiver is sending to the player. And with this, we have reached the end of this tutorial. I hope it can help you to get started quickly with the GFDM transceiver. If you need further information, don't hesitate to contact me. Thanks for watching and bye-bye.